Hello guys, chapter 3, part 1 is about chemical reactions and introduction to stoichiometry. Stoichiometry is the area of study that examines the quantities of substances consumed and produced in chemical reactions. But before we talk about that, we need to understand about chemical reactions. In chemical reactions, we have the reactants, right? And the products. So reactants before the arrow and products after. So in chemical reaction, you have the reactants, the starting materials in a chemical reaction, and the products, the ending materials. Then you have the coefficients, right? The coefficients so here you have the coefficients 2, so have 2 moles. The coefficients indicate the numbers of molecules or moles. So 2 hydrogen gas, 1 oxygen gas, and 2 waters. So when just 1, we do not write the number 1, right? So here you know that you have 1 O2. Okay, so in chemical reaction, we have reactants, products, coefficients, and subscripts. The subscripts here indicate the number of atoms of each element in a molecule. So coefficients, right? The number in front here. And the subscripts, there's ones. That indicates the number of atoms of each element in the molecule. For example, here, oxygen. We have 2 O, right? 2 oxygens here. And hydrogen, we have 2 hydrogen, right? This the coefficient here. Hydrogen gas has 2 hydrogen. But since we have 2 moles of hydrogen, that it means the total here you have 4, 2 times 2, 4 hydrogens, right? And the subscript indicates the number of atoms and the states of matter. Here, right, between parentheses, so gas, liquid. So solid, liquid, gas, or aqueous. And then we have, for example, here we have a combustion that is methane reacting with oxygen. This symbol here means burning and producing carbon dioxide and water. So balanced chemical reaction is to make sure that that each element has the same amount in the reactant side and in the product. For example, here, 1 carbon, 1 carbon. Okay. Hydrogens, 4 hydrogens, right? And here you have 2 times 2, 4 hydrogens, right? And about oxygens, 2 times 2, 4 oxygens. And here you have 2 oxygens from the CO2 plus 2 oxygens here from the water. So we have 4 oxygens as well. Here is confirmed, right? So it needs to match 1, 1, okay. 4, 4 hydrogens, and then 4 oxygens. What they need to confirm, need to balance. How to balancing? Change the coefficients, right? You cannot change the subscript. only the coefficients when balanced chemical reactions. So how can I start balancing? Start with an element that is only in one reactant and product. For example, here, carbon is only shown here and here, right? We start with, in the case with carbon. Then, so balance by changing the coefficients, not subscript. The one, like in math, one is not written because it's assuming that you have one. That is case here, one CO2. The next, move to other elements without changing the coefficients that they are set until complete checking all elements at the end. So usually let the hydrogen, then oxygen to be the last ones. So why do we add coefficients and do not change the subscript? The truth is because if you change the subscript, you are change the chemical here. Like for example, you need to balance a reaction that you need two oxygen. You have initially H2O and you need two oxygen. What we're gonna do here, I'm going to add coefficient, the number in front of the molecule. So now you have two H2O here. So like if you change the subscript, like for example, add number 2 here, you already change the molecule. You might change it for something else. In the case here, change it from water to hydrogen peroxide. So we don't change the subscript, only the coefficients, right? Now, how to balance chemical reactions? Let's start with the one that it shows just once, right? And then continue here. Let's see here. One nitrogen, one sodium, okay? So the next, what that says here, that says after, so after you check the one that appears just once, then balance hydrogen, then oxygen. So let's see what's hydrogen first here. So you have the two hydrogens here, right? But here you have two hydrogens and one. That makes three hydrogens. So now you have number 2 and number 3. So how can I balance it here? Like you have, for example, even number and an odd number. How to make it then to be the same amount? So let's multiply everything by 2 first. Okay, let's do 2 sodiums, 2 waters, 2 sodium hydroxide. Let's see how I want to change it here now. 2 sodiums, okay. Hydrogen, 2 times 2, 4 hydrogens. Now here, you have 2 hydrogens from here, right? And also 2. And then oxygen, we have 2 oxygens here. And also you have 2 oxygens here. And hydrogens, 2 times 2, 4. This one has 2 hydrogens plus 2 from this hydrogen. So the that case here, the balanced chemical equation is 2 sodiums, 2 waters, 2 sodium hydroxide, and 1 hydrogen gas. So this is the balanced equation here, right? The next one, let's see. So let's do the combustion one here. Propane, right? C3H8, oxygen, carbon dioxide, and water. Although it is a combustion reaction, then you have a compound with carbon, burned with oxygen will produce carbon dioxide and water. A combustion that organic compound always, like a complete combustion, always will make carbon dioxide and water. So we're gonna see more about that soon. Okay, but how to balance the chemical reaction, right? First, check the one that just shows ons. Let's see here. Which one just shows ons? Just have you have only the product, so the carbon here in the reactants, and this carbon here in the products. So let's start balancing carbon. How many carbons you have here? 3, right? So let me get this. Sorry. 3 carbon. Let's add the number 3 here. Right? Now let's check hydrogen. How many hydrogens you have here? 80 hydrogens, right? And here you have only 2 hydrogens. So which number multiplied by 2 will be equal to 8? So let's add it from number 4. So we have here 12 times 2, 80 hydrogens. So you are good here, right? Hydrogen is matching 88. Carbon, 3 carbon, 3 carbon. It's checking, right? Now the next one is number of oxygen. You have here, how many oxygens you have right here? Here you have only 2 in the reactant side, right? But in the product you have 3 times 2, 6 oxygens, and 4 times 1, 4 oxygen. That means in the product side we have 10 oxygen. So if you have 10 oxygen in the product, you need to have 10 oxygens in the reactant side. That means, I've seen number 2, right? For the O2, multiply by 5, 5 times 2, 10 oxygen, right? So that means the reaction is balanced by 1 propane, 5 oxygen, producing 3 carbon dioxide and 4 water. Okay, we talked about balancing chemical reactions, right? The next topic is about reaction types. So we have different kind of a reaction type. The first one is synthesis, that is also called combination here. So synthesis is a reaction in which 2 or more elements form a compound here. For example, you have hydrogen, and oxygen making water. So 2 combining to make the same one compound. So in that case here you have, for example, calcium and chlorine combining, right, to make calcium chloride. So synthesis is when we have 2 or more compounds, right? 2 more elements, 2 more reactants combining to just 1. Okay, for example, here you have the reaction A, the reacts AB, A plus B making AB. So AB are the elements and AB is the compound. So the synthesis reaction are also classified as oxidation reduction reaction. Talk more about that later. The decomposition reactions, the opposite of combinations. The composition reactions, you have one compound that's broken down into 2 or more elements. For example, here, had initially water, right? That was broken into hydrogen and oxygen. The composition is the opposite of synthesis. Synthesis combine 2 or more combined into 1, and the composition is 1 breaking down. into two or more elements. The composition reactions are also classified as oxidation-reduction reaction. Oxidation-reduction reaction. Then number 3 here, single replacement reactions. The reaction in which an element replaces one element in a compound. So metal can only replace a metal with lower activity. So you have a table that talks about activity. I'm going to talk about that soon. For example, zinc, right, is by itself here, reacting with copper, copper to nitrate. Why did I say two? Because copper is a transition metal, right? So that means this number 2 here indicates that the charge for copper is 2. So zinc reacts with copper to nitrate, will switch place here. That's why it's single replacement. So the zinc will be now together with the nitrate, and then the copper will gonna be by itself, right? This is a single replacement reaction. Then you have magnesium and hydrochloric acid. So magnesium, you take the place of hydrogen, and now hydrogen will gonna be by itself. Magnesium will replace the hydrogen position here. Single replacement, reaction in which the element replaces one element in the compound. Right. In single replacement reactions, a rule to use is like charge replace like charges. Metals form positive ions, so they replace each other. Yeah. So, like for example, we have just A and base C bonded, right? Then the A is gonna take the place of B, and B gonna be by itself. Right? The next one now is double replacement. Oh, don't worry. It gets better now. Okay. So double replacement reactions in a reaction in which the first two elements in each compound trade places. For example, here I have sodium hydroxide react with hydrochloric acid, right? What's gonna happen here? The sodium will take the hydrogen. The sodium will trade with hydrogen, right? So here, sodium hydroxide with hydrochloric acid will be the sodium and chlorine now, sodium chloride. The sodium will trade the place with hydrogen. And then the OH will now be with the hydrogen. So sodium hydroxide with hydrochloric acid will make sodium chloride and H2O. The same thing here, right? You have like, for example, sodium chloride with silver nitrate is also trading place above, right? The sodium and the silver, they are trading places here, right? So the sodium will become with nitrate, and the silver become with the chlorine. So the metals, all first one, right? So sodium is a metal, silver is a metal, so make sure the metal is all right first. 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . . 。 . 。 . . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 Then combustion. Combustion means burning. In a complete combustion reaction, we have a carbon-containing compound combine with oxygen and will make carbon dioxide and water. And this is reaction releases heat and light. For example, you have here 8 carbons, so octane here reacting with oxygen will make always the same, right? Carbon dioxide and water. It's not matter which compound you have here. If it is a compound like here with carbon reacting with oxygen, the complete combustion will make carbon dioxide and water. Why I said complete? So here, complete combustion reactions are recognized because they start with carbon containing compound in oxygen as reactants and they have only two products. The complete combustion will make only carbon dioxide and water. So highlight that is complete combustion. But sometimes you do not have enough, like for example, oxygen, and you have an incomplete combustion. So incomplete combustion occurs when something does not burn completely. So incomplete combustion reactions start like complete combustion, but have 4 products. Like also will have a carbon dioxide and water, and plus carbon monoxide and carbon, right? Okay, so we have here some practice problems. So to classify the reactions in balance, right? So let's start with the first one here. 1 copper and oxygen here. We have 2 reactants make 1 product. What is classification here? What's the reaction of this? Synthesis, right? So we want to have 2 or more reactants make only 1 product is a synthesis or also called combination. Let's balance it here. 1 copper here. 2 oxygens, and here you have only 1, so let's take number 2. So, okay, 2 oxygens here, right? And how many copper here? So let's 2. So 2 coppers, 2 coppers, 2 oxygens, right? And about the reaction 2, what's this classification here? What's the type of this reaction? I have 2 reactants, right? Make just 1 product, so this reaction is also synthesis, right? Now, magnesium, 1 magnesium, 1 magnesium, okay, right? Now, here you have 2 oxygens, and here we have only 1 oxygen. What we're gonna do here, 2 oxygens, so we need 2 oxygens here. When you change the oxygen for the product, we will also change the number of magnesium. So let's also add the number, write number 2 in front of magnesium. So now, 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens, right? When you don't see anything in front of the reactant, it means what? That you have only 1 right here. You don't write number 1, right? Okay, so then you have more problems here for you guys to practice and to balance. Oops, sorry. So here, copper, this one, right? Copper cobalt here, copper to cobalt. oh, sorry, copper to carbonate, I'm sorry. Copper to carbonate. So copper to oxide and carbon dioxide. You have here copper to carbonate, correct? And they compose into two products. One reacting two products. What's this classification here? The composition, right? Is breaking down. The composition, right? It's breaking down one into two more. Now let's balance it here. One copper, one copper. One carbon, one carbon. Three oxygens, one plus two, three oxygen. For this reaction here, it's already balanced without change anything, right? It's already balanced with 1, 1, 1. And about this one here, hydrochloric acid reacting with zinc, producing zinc chloride and hydrogen gas, hydrogen. So here, right, what's happening here? The zinc is traded place with the hydrogen to become with zinc with the chlorine here, right? And the hydrogen now is all by itself. So we have just one trade here, right? That case you call what? Single replacement, right? Okay. Now we need to balance the reaction, correct? Let's start with zinc or chlorine. So we have one chlorine here, and here you have two chlorines. So let's add right number 2 here. So now we have two chlorines, right? Let's check if everything else is balanced. One zinc, two two hydrogens, and here two hydrogens. So the reaction is balanced only right in the number 2 here, and it's balanced. And about this, the number 5 here, which reaction is this? So calcium chloride reacting with sodium hydroxide makes sodium chloride and calcium hydroxide. So you have calcium trading place here with sodium, right? Become calcium with hydroxide and sodium with Cl. So it makes sodium chloride. So we have two trades here. What's this reaction here? Double replacement, right? Okay, now let's balance the reaction. So one calcium, okay, let's not change anything yet. Two chlorines here. You have only one, so needed to write number 2 in front. When you change the number of chlorine, now you also change the number of sodium, right? So you have two sodiums here. So we needed to have also two sodiums here. Now let's check if everything is balanced. One calcium, two chlorines, 2 times 1, 2 chlorines, right? This is number 2, right? Let's multiply everything. That's after. Two sodiums, and two oxygens. Two oxygens, and two hydrogens, right? Now, the next one here, you have a organic compound with carbon, burn with oxygen, producing carbon dioxide and water. So this reaction is a combustion. Specifically, is a complete combustion because it's making only carbon dioxide and water. So complete combustion. Now let's balance the reaction. One carbon, one carbon, okay. 4 hydrogens, you have only 2 hydrogens, so let's add number 2 here. Now let's check the number of oxygen. 2 oxygen in the reactant, right? And how many oxygens in the product? How many oxygens in the product side? We have 2 oxygens here, plus 2. So we have 4 oxygen in the product side. You also need to have 4 oxygen in the reactant side. So let's write number 2 right here. So 2 plus 2, 2 times 2, 4 oxygen. So the reaction now is balanced. Okay. The next topic is about formula weight in molecular weight. So formula weight is the sum of atomic weights for the atoms in a chemical formula. For example, calcium chloride, you have 1 calcium and 2 chlorines. So you go to the periodic table. Where is the periodic table? Let's get here. The periodic table you have calcium here, 40.078. Or can be just 40.08, right? We'll have only 1 calcium, so 1 times 4, 40.08. And chlorine. What's the atomic weight for chlorine here? So 35.45. And here, the periodic table that was used here in this note used 35.453. So you're going to add up 140 plus 2 times 35.45 because you have 2 chlorines. So the atomic mass, the formula weight here is 110.99 AMU, that means atomic mass unit. Formula weight are usually for ionic compounds, right? And compounds usually want to have what? Metal plus no metal. The molecular weight is the sum of atomic weights for atoms in a molecule. So molecules, when you have, like for example, no metal plus no metal, like here. Carbon is a no metal, and hydrogen is also no metal, so we have here a molecule. So carbon, each carbon in a periodic table is 12.011, and each hydrogen is 1.008. I'm gonna round it here just. So how many carbons do we have here? 2, so 2 times 12, 1.011, plus 6 times 1.008 here. You want to adapt, you have 30.07 atomic mass units. How you find the formula weight in molecular weight? The math is the same, right? Just change the name. Right, the next topic is about moles and moles conversions. In a lab, you cannot work with individual molecules because they are too small. In 1 mole is the amount of particles found in exactly 12 grams of carbon-12. So 1 mole of atoms or molecules will have 6.02 times 10 to the 23 atoms or molecules. So 1 mole of particles, you have this amount here of atoms or molecules. And molar mass is the mass of 1 mole of a substance in grams per mole. The molar mass of an element is the atomic weight, for the element from the periodic table. The difference is the unit, basically. So the formula weight or molecular weight, the unit is atomic mass unit, AMU, and the number is the same, but for molar mass, the unit is in gram per mole. So molecular weight, formula weight, unit, atomic mass unit, and molar mass, grams per mole, right? Okay, so what's the molecular weight of H2O? So what are you going to find how many hydrogen, you have two hydrogens, right? Each hydrogen here is 108, right? 2 times 108 atomic mass unit. Oxygen, how many oxygens you have here? Only one oxygen, right? And each oxygen is 15.99. And then you are going to adapt here to find the molecular weight of water. The math is the same, just change the unit. For example, here, 2 times 1.01. To find the molar mass, the math is the same. Just change the unit. How many oxygens have we here? Only one. So 1 times 50.99 grams per mole, right? And then I'm going to adapt here. When the B should be 18, around 18, right? So the unit here will be atomic mass unit, and here unit will be grams per mole, right? Okay, okay, so I'm gonna pause it here.